techniques where we say we have the probability sampling, which is a sampling method that gives equal opportunities for participants in the study. And we have the non-probability sampling techniques where we say the non-probability sampling that is mainly for those that not all participants are eligible, but those who participate in the study, there is something critical, there's something important that makes them the right persons for the study. So we said for the probability sampling, we have this simple random sampling technique. We saw what it is. We talked about the systematic, the stratified sampling, and the last of the probability sampling was the cluster sampling method technique. For the non-probability sampling, we said not all participants of the study population are eligible to participate for some reasons, and because of that we have different types. We saw convenience. We say with convenience sampling, one thing that influences the choice of somebody to participate is based on the person's availability and accessibility. The person is available, accessible, and willing to participate in the study. We saw that we have the snowball technique where you don't pre-have your sample or your population, but how you get your population is through referrals or recommendation from those that you've already contacted. And we saw the quarter sampling where you choose to get a certain proportion of your population to represent the population. We saw purposive, and we say with purposive, those who participate in the study, there is something peculiar that make them eligible for the study. And we said in either situation, you want to get data, and the data should be able to answer your research questions or to help you attain your research objectives. For the probability sampling techniques, we said they are mostly utilized by quantitative researchers, where their motivation is to verify a hypothesis or to test a theory. And in doing that, they already start your study with a hypothesis and expectation, a presumption about your study. And you collect data to verify that hypothesis. And one of the things that makes it is that it's this question of the population that can, or to get a sample that is a representation of the population. And to do that, you need to get enough participants or enough persons to participate in this, take a sample that is a reflection. We said there are different sampling techniques, sample calculation techniques. We have the Lorentz, the Morgan, and the table that you can use to actually determine what sample size is adequate for your population. We equally indicated that if your sample size is a representation of the population, then there is high possibility for you to be able to get a sampling mean, a sample mean that represents or that reflects somehow that can depict the population mean. And it's on the basis of that that we can equally get information from the sample and use inferential techniques to generalize with respect to the population. From population and sampling, we went on to the different levels of measurement in statistics. We said our data can basically be classified into 4 levels: the nominal, the ordinal, the interval, and the ratio scales. A proper understanding of this different categorization of our data is very, very important because it plays a key role in your analysis. So if you don't understand your data, you won't be able to do right analysis because you may be doing analytical techniques using data that is not apt. From there, we saw that the nominal simply represent naming of our variables, categorizing our variables without an intrinsic order. Example we said was gender, types of colors, and we went there to we said there is no absolute zero. Actually, some questions guided us. For ordinal, we say why we have the aspect of naming and categorizing our items. We have an order that we can use to draw our conclusions. We can arrange from the least to the highest, or there's a particular pattern that we think that the data follows. We gave example levels of education. We equally gave example maybe assigning students marks, or maybe assigning students first position, second position, third position. One thing that makes the ordinal different from the nominal is the order, but the things that makes the nominal different from the interval is that there is no equal distance between items. You won't be able to say what a position or what is the difference between the first and the third position, or the first position and the second position if we want to categorize. We gave examples like levels of education, maybe levels of classes from 1 to from 5, and so on. There is an intrinsic order that we notice. We said because of that we have the interval, which with the interval we can have the naming of a variable, we have an order, and we equally can factor out the distance between one element and another. We set student marks. So a student marks, we give exams on 20. A student that scores 18 is 2 times more than a student that scores 9. And the difference between 18 and 15 marks can easily be calculated out, and we will know with certainty. So, but however, the interval, there is no absolute zero. And so zero seems to represent the total absence of the variable. And so we have the last option, which is the ratio scale. And we saw that the ratio scale, it carries the attributes of all the first three that we have seen, but that the absolute zero is useful. And so we cannot ignore that, which is the most common example to illustrate that. We ended the levels of measurement by stating that with levels of measurement, we need to be able to understand that we can basically classify into two. We have the categorical and we have the continuous. Now, with the categorical data, we simply classify our data under some particular categories with finite options. But with the continuous, we cannot actually classify our data into finite options. Their options are limitless, or even if they're finite, but we have a lot of, say, it's continuous. For instance, your age can really can somehow be continuous because you have maybe 12 years, out of a sudden you're 13. And within that levels of years, there's so many possibilities. You have 12.1, 12.2, and so on. It is continuous in nature. And so this is how we calculate. We also said for continuous data, we can classify into discrete and continuous as well. Discrete now refers to data that may be whole numbers, and in which case even some categorical ideas can be represented as discrete data. The continuous data has to do with decimal places, their fractions, and so on and so forth. I'm sure that's what we said with respect to the levels of measurement and maybe other things that we indicated with examples. From levels of measurement, I think the next thing we saw was variables. We saw that variables are very, very important. Actually, all your analysis is manipulating variables and seeing how they affect one thing or the other. A whole research topic is focused on understanding the relationship between one variable or examining the effect of one variable on another. And so what is a variable? We said a variable refers to any attribute of our study that has a potential to change, has a potential to take on more than two values. Yes, it's not constant. The opposite of a variable is a constant. And we equally said a variable is simply assigning two options as I've indicated, or two or more options. For instance, when I say gender, you automatically, by default, should be thinking of either. But if I say male, you don't have classification because it's simply a constant. We set a variable in a research topic. We have principally two types of variables, the independent and the dependent variable. Now, for the independent variable, it is a variable of interest that we manipulate to see how it affects the dependent variable. And the dependent variable here refers to the outcome variable, the variable that we are trying to examine the effect. So it's the outcome, the criterion variable. And so this topic, we embody this type of, except it's a purely descriptive study. Research, we may not have which one is dependent and which one is an independent. And maybe in some correlational studies, we may not say exactly which one is dependent and which one is independent. But we have techniques that can help us to identify, to analyze the data. We went further from there to set, apart from the dependent and independent variable, which are the primary variables of the research topic, we equally have extraneous variables. External variables on their part are those variables, our dependent variable, and we are not particularly interested in examining the effect in our study. And so external variable at times, we may not really be directly manipulating, but we must be able to cater for their effect on the dependent variable. And now there are different types of extraneous variables. Some call them intervening variables, and so on and so forth. And we said we have mediators. We equally have moderators and confounders. Now we say with the mediators, these are variables that transmit the effect of the independent variable. And we gave an example for quick understanding. We said if I'm a student, I sit in a class and the teacher is giving notes. And I sit the notes, and in the course of preparing for exams, I really desired, I don't have notes to read. And Andrew, who copied notes, I took his note. Then at the end of the day, The act of copying the notes. If you see my slide, indicate please. If you don't see, let me know. Might not influence performance because we need to introduce an intermediate or intermediary variable, which is reading. And we said, despite this, there are some situations that we have what we call partial mediation, when without the mediator, the dependent variable still has a significant effect on the independent. I mean, the independent variable still has a significant effect on the dependent. And partial full mediation is when, with the introduction of the mediator, the independent variable ceases to significantly affect the outcome variable. We said apart from mediators, we equally have moderators. These are just variables, or a variable that its effect on the outcome variable, which is a dependent variable, depends on the level of categorization of the independent variable. We saw example of gender with respect to athleticism, especially running long distance. And I said why we have separation of students or athletes from male and separate male and female is because their performance is tied to the gender aspect. If performance tied to gender aspect, you won't be able to do a proper assessment. So such a variable is considered as what? A moderator. Levels of education can still act as moderators. Maybe you are somebody with a university degree, first degree for instance, may perform better in a task than with advanced level. And so in such a case, education is a moderator with respect to whatever you are trying to examine the performance, as we've said. We said the last type of variables that are of interest to us is the confounders. And these confounders are variables that have a tendency to influence our dependent variable that directly controlling, and that if we're not very careful, we may draw wrong conclusions about the effect of the independent variable on the dependent variable simply because the confounder is actually the one influencing our outcome. We gave an example, and in the example we saw that in the example we saw the case of using we saw the case of drinking alcohol and having lung cancer. Now we said many times there's a possibility for you as a statistician to, or a doctor in the hospital to say, when you go home today, don't drink alcohol again for somebody with lung cancer. And the reason is that the person who is drinking the lung cancer has a potential, drinking has a potential to have lung cancer. But it's not the drinking that may actually be responsible for the cancer. It's because the person equally smokes. So most of the persons that smoke, they drink, and most of the people that drink smoke. And so you may just, drinking has a high correlation with smoking, with lung cancer, simply because in collecting our data, most of those that we drink are drunkards, are at the same time smoke. And if we decide to take the smokers, we discover that most of them drink. And so you need to be able to factor out the influence of this confounding variable. That's what we guys, the effect of all these other variables, so that we can actually seclude the effect of our independent variable on the dependent variable. And so I think those are the key concepts we saw, and get my attention to that. And for today, we will look at research questions. We'll talk about hypothesis testing. We'll talk about the significant levels, confidence interval, degree of freedom, and a good number of okay. I assume that we are all okay up to this stage. Now, sorry, we keep having this network failure. Okay. So before the network went off, we said today we'll be looking at the different research questions we'll see hypothesis testing. Now, let's start with research questions. In carrying out a study, especially quantitative studies, which basically constitute our area of interest as this course is concerned, we have three types of research questions that you likely have to address or to ask in order to provide answers. Now, the three types of questions, we have the descriptive research questions, we have the comparative, and we have the relationship research questions. Now, These questions are very, very important because they help you to be able to establish, to know how your data will be analyzed, and to even choose the right analytical techniques when you set out to analyze your data. For instance, if you are doing a descriptive study, it is obvious that you get bad descriptive technique to analyze the data. You use descriptive methods to be able to provide answers to your research questions. And so an understanding of the way the questions are performed is critical. Now, having the different types of research questions are descriptive, comparative, and relational effect. You need to know how to structure these questions. You need to be able to know that most of the students, if you are in academia, or you're a supervisor or you're a researcher, or if you are assisting students as a data analyst, they will come with their manuscript and say, I have issues with my objective, I have issues with my research question. And when you are setting this research question, you must be thinking of what the person wants to get and how is the data going to be analyzed and how is the data going to be collected. That's where you have to look back to the levels of measurement. How will the data be collected and what categorization will the data be? And for the methodology section, you need to decide how the data will be analyzed based on an understanding of the type of research question the person have used. Now, I have this guideline to help us in checking or in establishing research question. The first step is that you need to choose the type of research question that you desire to carry out to be able to answer in your study. Are you choosing descriptive, comparative, or relational? Now we'll talk more what descriptive entails, what comparative entails, what relational entails. The second is you have to identify the different variables. You see, while we are still trying to review concepts, we're already trying to apply some of what we know. We talked about the population, we talked about variables and the levels of measurement, and now we are saying you need to identify the different types of variables you are trying to measure, or you want to manipulate, or you want to control. And any group that you are interested, the group that means population. You may be interested in evaluating if there is any significant difference with respect to academic performance of students as gender is concerned. And so your group becomes the gender, and you are looking for differences. So basically, what we will be trying to do is that you are doing comparative analysis. You want to compare something between two groups. In this case, you can have a single variable, let's say academic performance, that is, and a single dependent variable and a single independent variable, which is Keeps going on and off. So we ended with the second step, which is identify the different types of variable found in your study. We saw that you need to know if you're dealing with particular group. Now you have to select the appropriate structure for the chosen type of the research question. And this is based on combining either their variables or their groups. For instance, you may set a research question, so you may set out to examine the differences or what is the effect of alcohol on let's say effect of alcohol on the body temperature. Let's just take as an example, or liver. Now with that, you want to carry out data. Your variable there can be your variables here has to do with the alcohol and the body temperature, as we've seen.
Michel. 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 Michel, je ne t'appelle pas.
So you have to identify, and the last part is just simply writing out. So in the course outline or in the notes that I sent, you'll see that if you take the descriptive research questions, the first thing is for you to be able to describe. You just want to describe a situation. You just want to describe, maybe you want to look at the prevalence of a disease like malaria. You want to examine how often something happens, how frequent something happens. Maybe you want to examine how much, to what extent. And so you discover that these are descriptive research questions. And so you have to be able to structure them and understand that it will warrant you to use the descriptive techniques to analyze your data. So that's what you must consider. Now, for the comparative research questions, you will understand that you want to compare, and in comparing, you can only do comparison when you have at least two groups. You have at least two groups. You can compare male and female. You can compare maybe trained and untrained, educated and uneducated, happy and sad, sick and healthy, and so on and so forth. Now, you must understand that in order for you to do comparison, you may have one dependent variable, one independent variable. We categorize into different categories. You may have one or more categorized into different categories, and the dependent variable, which can be, in most cases, continuous in nature or not. And whatever type of questions or the number of groups involved will determine the analytical technique that we use. For instance, if you're comparing two groups that are unrelated, right? We can use what? The independent sample t-test, in which case we know that elements in one group are exclusive and mutually exclusive. You cannot be in one group and the other group at the same time. You must, if you're a he, you're a he, and you cannot be a he and she at the same time. So if you belong to the group of he's, you are in that particular group. Now, there are some moments we may have to use a repeated measure such as a per sample t-test, because we are comparing maybe the same persons over different outcomes, over different situations, maybe different times. If I want to compare the performance of the same student between first and second semester, then I will use maybe the per sample t-test. In a situation where you have more objects, more than two groups, there are other techniques that you can use, like ANOVA and many others. So in setting up such research question, you have to still start with the starting phrase, such as what is the difference, what is the effect. You have to identify and name the dependent variable. For instance, if you look at this question, what is the difference in the daily water intake of men and women in Douala? Now, the first, we have the starting phrase, which is the what is the difference. Now, we have the daily intake of water between the daily, we are looking about intake of water, and this constitutes our groups of interest. This is male and female. You can now put the context, which is Douala. So, in effect, what are we saying? Yeah, that network is really a challenge for everybody. I don't know if you guys are getting me. We identify and name the dependent variable, identify the groups of interest. For the group of interest, we've said men and women, and identify the appropriate adjoining text. Now, you want to examine the difference between daily water intake between of men and women. So, and it's like the adjoining text. If you go to what is the difference in the weekly photo uploads on Facebook between, you still see that we're talking about male and female. So once you do that, you are writing, you are able to see how your research questions will come into play. Such type of questions are described as what? Descriptive research questions. Now, we have the last part of research questions, which has to do with comparative. I don't know why I don't have it here, but the last part of research questions are the correlational or the relationship research questions. And with these questions, we basically want to compare two variables. We want to examine if there exists any relationship between two variables. Maybe do we have any relationship between education and earnings. For instance, we want to examine if more you become educated, the higher your earnings. You can establish a relationship. So we collect data with respect to the levels of education, and you collect data with respect to pay, and try to establish, evaluate, and see if there is a relationship. What is the nature of the relationship? how strong is the relationship, and so on and so forth. In such a case, you may want to see the effect of one variable on another. Now, there's a slight difference between establishing just the relationship and examining an effect. Now, if we talk about, for instance, when we see in our course, we'll talk about correlation. We talk about correlation where examining if there is a relationship. But we may use regression to examine. Now, we've talked of the relationship between academic qualification and earnings. We may equally conduct a study to examine the effect of academic qualification on earnings. In such a case, we can use different techniques to analyze the data. So like we said, you must choose the type of variables, choose the phrase that you intend to use, identify the variables, because for correlation or relationship question, you need to have at least two variables. Yes, you have at least two variables before you are able to do that. So any question with respect to what we have seen about research questions for today? Okay, if we don't have any question, the next key concept of interest for us will be parametric and non-parametric data. Now, I would not like to really talk much about parametric and non-parametric data, especially when we don't understand what a normal distribution is. Now, we will need to see what a normal distribution is before we get back to parametric and non-parametric data. Now, the next concept I prefer we take will be hypothesis testing. Hypothesis testing. Now, as a data analyst or a researcher, and a quantitative researcher especially, when you are carrying out a study, you have to collect data from a sample. Now, the data you collect from your sample will be irrelevant if it cannot help you to infer with respect to the population. In other words, nobody is interested in the sample you have collected unless that sample can be applied to a larger population. And so if your sample limits itself just to the population, it becomes difficult. And so in order for us to collect our data, gather with a large sample size, and from the sample we make inference to the population, then we are simply doing what statisticians will say, hypothesis testing. But what is a hypothesis? Now, a hypothesis in the world of research is considered as what? An educated guess about a situation around you, or it's an assumption. I know we have seen the concepts. It's an assumption. It's a tentative answer to your research question. If I say, what is there any difference in the water intake between male and female in Douala? I can convert that to a hypothesis by saying that there is no difference between the level of water intake in the water intake between male and female in Douala. Now collect my data to verify. So in other words, you want to collect data to verify this assumption, to answer your research question by making what? An assumption. So like you see from my slide, I said the purpose of inferential is to test a hypothesis. Now we've not talked about inferential, we'll get back there. And you might run an experiment and find out that a certain drug is effective in treating a disease, say malaria, which is a prominent disease. But if we collect your data and we cannot repeat the data to have the same experiment to be applied to a larger population, then your results are not useful. That's what I said. So with this idea about a hypothesis, you assume an outcome. Collect data to prove whether your assumption is right or wrong. For instance, we may say, if I increase my water intake, what happens to my weight? Now, that's not yet a hypothesis. But if we take that decision, we want to put it, we say, water intake leads to increase in height. We cannot collect data in weight. We cannot collect data to verify whether that assumption is right. Now, in statistics, we will always assume that there is an effect. There's a relationship. And so we don't only end at, is there a relationship? But we are very much interested to know if that relationship is significant or not. Yes. And we are very much interested in the aspect of significance. So you want to be certain that variable A has a significant effect on D. And I try to give an example to guide you on how you can set your research hypothesis. And to do that, you may basically start by saying, if you are trying to look at your dependent and independent variable and try to bring them together. If I do this to the independent variable, then what happens to the dependent variable? Remember, we earlier indicated that the independent variable is the variable we manipulate, is a variable we have control over to just to alter into different levels and see we are saying in stating your hypothesis, you always have to assume a relationship to try to establish that if you do this to your independent variable, then what will be the effect on the dependent variable? For instance, if I decrease the amount of water given to a plant, then what will happen to the plant size? Will it increase? Will it decrease? If I give patients counseling in addition to medication, then what will be the overall depression level? Will it increase or decrease? And so on and so forth. It is from the linkage of these two, the dependent and independent variable, that a hypothesis is established. Now, in real world, you must state your hypothesis before collecting data. You don't collect data before stating a hypothesis, because there's a tendency that your hypothesis will be biased when you collect data before stating the hypothesis. So you need to have your hypothesis. That's why hypothesis are stated. So generally, we have two types of hypotheses in research. We have the dependent and the null and the alternative hypothesis. Sorry for me. Now, the null hypothesis, which in most cases is denoted as H0, is usually what prevails purely from the sample. What we think will prevail from the sample by chance. So, in other words, I said The null hypothesis basically observes the results purely by chance. While the alternative, on the other hand, says that the underlying difference or effect or situation we're observing results from the data. Now, when stating a hypothesis, I always want to give a simple example. Let's assume that you are a teacher, or you're a teacher, and during classes, some students are disturbing. Let's say there are 3 or 5 girls. And because of that, you decide to punish the girls and give them an exercise that they will need to mop the classroom for 2 weeks. Now, once you have given the exercise, okay, after giving the exercise, the students decide on how they are going to solve the problem, and they say they will use a sampling method. Since they're statistics students, they want to use what they have learned in their statistics to solve the problem of mopping by ensuring that not all of them sit back every day to mop. Rather, they will do random sampling with replacement, and each day when they come, they will write their names, put in a basket, shuffle at random, and pick out one person. And the person that the name that is picked, the person will do a mopping. Let's assume that this is the decision that the 5 girls have decided, and the girl who proposed this decision is Mary, just as an example. Now, Mary has suggested that for them to solve this problem of not everybody mopping, we should use a random sampling with replacement, so that each day we come and pick a name. And everybody thinks that it's a fair decision to adopt that random sampling technique and select who mops per day. Everybody have decided, okay, we're starting today. The first day, Cynthia picks. The second day, Stella. The third day, let's say Anna. The fourth day, Belta. And Mary has not picked, or has not been picked for mopping. Now, what happens is that after picking for 4 days, everybody is happy. Nobody starts suspecting that there is anything happening. And so, at this particular stage, we basically think that no, we have a fair situation. But the 6th day, we decide to still continue, and after the 6th day, we discovered that Mary has not been picked. What's happening? We maintain that, okay, well, Mary has not been picked simply by chance. There is no underlying thing that might have caused Mary not to be picked for the exercise. The 7th day, almost the same situation. Mary has not been picked. So, even after the 7th day, that she has not been picked, the 8th, the 9th, the 10th. What happens is that we will grow suspicious, right? We'll start suspecting that, hey, don't you think that there's something happening? Why is it that people have been picking, and Mary, who did the suggestion, has never been picked to mop the floor? There should be something going on somewhere that we need to verify. After the 10th day, everybody have done it twice, and some people have done it 8 times, but Mary has never been picked. Our level of anxiety of thinking that Mary has not been picked by chance reduces, because each passing day, the probability of Mary being picked is reducing. Not picked, is reducing. And so we have to go up to a certain extent. Maybe after the 12th day, we say that, okay, whatever is happening now is no more by chance. There is something that makes it impossible for Mary to be picked. So What are we trying to explain? We're explaining the concept of significant level, the concept of hypothesis testing, and how we establish our alpha level. Now, for the 12 days, we basically assumed that it was by chance that we're not picking. But after the 12th day, we refused to accept that it's by chance that Mary has not been picked for such an exercise. So we have that level of assurance, that level of confidence that we are ready to say our results are by what? Chance. So in hypothesis testing, we are basically trying to verify our hypothesis by assuming that whatever is happening is not by chance. There is an underlying situation that prevails in the population. And that at the same time, we're talking about the confidence interval. So when you are trying to verify your hypothesis, you are trying to see that whatever is happening can be generalized as what? The normal state of affairs to the population, not only to the sample, but to the population itself. Yes, you try to generalize the normal, that this is the normal state of affairs, or not. That's why many times we say there is not enough evidence for us to conclude that this is happening. You don't have enough evidence to conclude that Quaterm is a good drug for malaria. There might be an evidence, but that evidence is not enough. After the 7th day, we are suspecting that John can be cheating, or Mary is cheating, right? But we don't have enough evidence. After the 10th, we don't still have. And so we need a certain level of assurance to decide that John is cheating. Now, that's one way to talk about the what? The significant level. In other, what is the significant level, so to say? Now, the significant level basically tries to establish the strength of evidence that we must have before rejecting what? Our null hypothesis. That's why I said this hypothesis, testing, significant level, and so on, they are all related. They have something in common that you must be conscious of as a data analyst. They have something in common. The significant level tells you that you need a certain evidence for you to decide whether whatever you are trying to test prevails beyond reasonable doubt and it's not by chance. Let's give another possible situation. Let's assume that somebody has been accused for stealing and he has been caught, or we just say a thief, and somebody has been caught, and after the person has been apprehended, you take him to the court. In the court, what happens is that they apply the principle of hypothesis testing directly or indirectly by looking for what? Asking for evidence to prove your claim that this person has stolen. Now let's assume that the judge decides that, okay, we will sample 100 persons to either confirm that this person is a thief or not a thief. Now, from the judge's decision to sample 100 persons, he needs to set a confidence interval beyond which he will conclude that this person is a thief or not a thief. He needs a certain level of evidence. That's why we may provide evidence 1, evidence 2, evidence 3, and so on and so forth. But let's take it to a study with the 100. The judge may say, okay, if 60% says you are a thief and 40 says you are not a thief, then I'll let you go because I don't have enough evidence. This 60% saying you're a thief can simply be by chance. Now, if 70% says you're a thief, well, I might start thinking that you're a thief, but I still have enough evidence. The strength of my evidence is not enough for me to actually conclude that you're a thief. But 90% of those we sample says you're a thief, then you go to prison. You're a thief. In this case, the the judge has said what? A level of a significant level beyond which the judge will conclude that no, 90% of these people, or these 90 persons that have said you're a thief, they cannot be by chance. Truly, you should be a thief. Then we have 10%. We have 10% that stands for the idea that you are not a thief. There are two possible things that you need to note with respect to this example. The 90% can still be wrong, and you'll be sent to prison. Right? The person might still not be a thief, but 90% of people think you are a thief. So we have what we call the type 1 and the type 2 errors when we are analyzing. Now with the type 1 error, we simply reject our null hypothesis when we ought to, we return our null hypothesis when we ought to reject. Which means, for instance, we are saying that this person is a thief because 90% of the persons have said he's a thief, while in reality, the person is not a thief. Then we have the type 2, which is just a reverse. We say the person is not a thief when the person is actually is a thief. So we have the type 1 and the type 2 errors, they're opposite. When you decide to look for more evidence, if the lawyer or the judge says, I want, out of the 90%, out of the 100, if 95% of the people, or which means 95, says you are a thief, I will send you to prison. We have reserved 5% to by chance. There's 5% that we're saying that 85% are saying you are not a thief is by chance, and we cannot draw that conclusion. So, in other words, we need to set our significant level based on the probability of what? Rejecting when our null hypothesis is true. For example, a significant level of 0.05 indicates what? A 5% risk of concluding that there exists what? A difference when there is no actual difference. We have a 5% risk of saying that this person is a thief when the person is not actually a thief. Right? We have a high potential, a 5% risk of saying that though that Mary, who was not selected for the 12 days, is cheating when what? Mary is not actually, when Mary actually is not cheating. That's the concept of significant testing. And the significant level, we should talk about the strength of the evidence that must be present in your sample before you reject the null hypothesis to conclude that there is statistically a significant effect. Now you are the researcher to determine that. And when you are determining the significant level, we have indicated two possible errors you can make. The type 1, where you say the person free while the person is actually a thief, or you say the person should be in prison when the person is not a thief. Or we are saying that Mary is cheating, but she's not cheating. It's just by chance that for 12 days, her name has never appeared on the paper. We conclude that Mary is cheating because we have exhausted our confidence level or our threshold, the strength of evidence that we've set. So in this, we are saying that we have the significant level. Now the significant level established to us what we call a confidence interval. A confidence interval basically talks about the range of values for which you think that your results are not by chance. So a significant level gives rise to a confidence interval. Put a statistical principle, we are referring to a range of values for which you think that your sample mean reflects the population mean. That you know that if you are, let me say, you know that you are 95% confident that if a lady is above 20 years, then her weight should be 50 and above. That's just a simple example, it may not be scientifically right. You have a certain confidence that any lady that is above 20 years, her weight should be what? Above 50 kilograms. Now, in reality, we may not have exact 50, but we have a range of values. That gives what we call now the confidence interval. Maybe we say it's between 45 to 60. And your sample mean can be what? If your sample mean is 10, let's say 50, and you have a confidence interval of 45 and 50, you are saying that this is our sample mean. But I know with 95% confidence that my population mean will be between what? 45 and 60. In other words, out of 100 ladies above 20, I'm confident that their weight will be between 45 and 60 because I have what? My sample, which was a representation of the population. Now, in our previous class, we talked about the central limit theory that establishes this principle, and we are able to apply it here. So you have that assurance, we have that confidence that your sample gives you the point. Now, we have the p-values. The p-value simply gives you what? The probability. If you say 95, in other words, it can be 0.95, and we have 0.5 to give us 1. Remember, probability will always be equal to 1. Now, when we take the 95, there is a 5% to give us 100. 100 divided by 100 will give us 1. And so we express always express as probability. When we are expressing as probability, we want to have a p-value. Now, the rule of the game says that the strength of evidence in support of a null hypothesis is measured by the p-value. The p-value is the probability of observing a test statistics as extreme as the sample, assuming the null hypothesis is true. Okay, sorry for that. Oh, I think I'm recording the class, and so you'll be able to send the link, the platform, so you can get access to it. So the set of values outside the region, we said it is what? Assuming that the hypothesis is true. So p value gives us the probability. When we get to application, you'll be able to see this. And so we'll be able to see how they work, the application part. Now, the set of values outside the region of acceptance is called what? The rejection zone. Now, we have set 45 and 60, but there are values below and the values above. This form the rejection zone. Now, if the test falls within the region of rejection, the null hypothesis is rejected. In this case, we say that the hypothesis has been rejected at the alpha level of significance. We'll be able to understand better. So we have the acceptance and the rejection zones. Now, let's talk about the normal hypothesis so that we can put the concepts all together for proper understanding. We have the normal distribution, which is equally also known as the Gaussian distribution. And this is a distribution that is symmetric about the mean. In other words, the idea about the normal distribution simply tries to establish what happens as our mean is concerned. Others call it the bell curve shape. Now, let's say that we collected data for 100 participants. Now, we wanted to examine the performance of students in class, and we collected data for 100 students. And what we did is that the exam was on 20. So our exam was on 20, and after calculating the mean for the 20 students, we have a mean of 12, right? With a mean of 12, that is the average. Now, according to the normal distribution, majority of the students will have their score close to the mean. Further away from the mean, we have reduction in the scores. And that is illustrated by this shape that we have here. This is the shape of the standard normal distribution. This is our mean. This is the mean, which seems to be the highest point. And we have majority of the respondents along this area. Now, taking this example, let's assume that our mean is 12 and our standard deviation is 2. Then the rule says that using the standard deviation rule, it says that 68% of our participants will have their score between plus or minus 1 standard deviation. Plus or minus 1 standard deviation. What are we saying? In other words, with respect to your example, we're saying that since our mean is 12 and we have a standard deviation of 2, 68% of our students will have their marks between 10 and 14. If we check here, if you see from this my example from the slide, you will be able to see that we have our mean here, which is abbreviated U, just say mu, and we have the mean minus the standard deviation, and the mean plus the standard deviation to give you the lower limit and the upper limit. And so we have 68% of the sample will be at this point. Then 98, apart from that, 95% of our population will fall between plus or minus 2 standard deviation. That's what we are saying. So in other words, we are saying that 98% of the students, 95% of the students, let's say 95% of the students, or 95 of the students, if we're using frequency, assuming that there were 100 students, will have their score between 8 and 16. Now, out of this, we may have what we call outliers, those who are the extreme. Now, this curve is something of this nature. Let me just take eraser. It's something of this nature. We have this, and the curve goes like this. Now we keep going, plus or minus, but it will never reach 0. So it's something to infinity. It will get closer and closer and closer to this line, but it will never get to 0. So it's important for you to understand. So when our data is distributed, and assuming this normal distribution as the bell-shaped curve as we have seen, and a symmetric in nature, we are saying that we have 50% to the left, 50% of participants above the mean, and 50% below the mean. And that 68% will have their score plus or minus the first standard deviation, plus or minus the second standard deviation will be 95, and maybe the 5% will form outliers. And so if your data follows this pattern, then we call it a normal distribution, a Gaussian distribution. I always try to exemplify this with maybe giving some examples. Let's assume that you are studying something that prevails in the whole community. Let's take a tribe. If I call a tribe, say Bayangi, if you're from Bayangi land, then you basically, or not necessarily from Bayangi, and you know them, there may be something that is so peculiar to them, right? That is like the average. And so most people will attribute will exhibit that average. As we move further away, that attribute will be reducing, just to help you understand this principle. So, a normal distribution, also known as the Gaussian distribution, is a probability distribution that is symmetric above the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. And we graph this to have what? A bell-shaped curve. Now, a normal distribution is a proper term for a probability bell curve. And in a normal distribution, the mean is 0 and the standard deviation is 1. And it has a 0 skewedness and a courtesy of 3. Now, some of about skewness, courtesy, and the rest, you might not understand them now, but we'll see as we progress. However, just to say, when we talk about skewness, if your data doesn't follow this pattern, then it obviously follows another pattern. And the possibility could be that we may have, if this is we may have a shape of this nature. Our mean may be here and not at the center, and we have majority. Now we have skewness to the right and skewness to the left. We may have something of, let's say this is our mean here, and we have more of the data to the left. Sorry, I am not good at drawing, but that is how it goes. So we have positively skewed and negatively skewed. And we also talk about the courtesy of the distribution, and the courtesy of distribution talks about the flatness or the peakness of the curve. So we may have a curve of this, let me check if I have a sample. This is about normal distribution. I seem not to have a sample here. So, what are we saying? We have courtesy that talks about the peakness of our curve. Peakness can be flat at the bottom or flat at the top. If you've done population studies, we know that majority in Africa, they have the seemingly majority at the bottom, the youth. As we go, we have the elderly and they're reducing. And as we go to some countries, we see that they may be high at the top and so on and so forth. That's trying to explain the principle of courtesy. So I have the notes here that talks about situations of normal distribution. A normal distribution called bell shape. We have examples of height of people. Height most often follows a normal distribution. Majority of the person, adults, will be between 1.5 inch to about 1.6 or 1.7. And as we move further to 1.8 and above, you see that will be reducing. And the outlier may be somebody who has 2 meters tall. So that person becomes an outlier. We have measurement error, blood pressure points on a test, salaries. We can see that they all follow the principle of that normal distribution. Now, if something doesn't follow a normal distribution, you cannot generalize. Now, based on the idea of normal distribution, we talk about the parametric and non-parametric. Now, the parametric data or parametric analysis are analyses that assume that your data follows the pattern of what? A normal distribution. So that when you are concluding about 68%, which is 34.1% plus this, it is because we are sure that whatever we get from the sample can represent this area. That's 68%. I'm sure 68% or 69%. will give you that. And the 95% will be from here to here. And you see plus or minus the standard deviation that we have indicated. So that is what we see with respect to the probability distribution and how we can manage it. So, any question? So far, we've talked about the confidence interval, and we have the notes to read some of these concepts. I've done the general explanation. So go over the notes and see a confidence interval is a range of values that are likely to include a population value with a certain degree of confidence. It is often expressed as a percentage whereby a population mean lies between an upper and lower limit. Like I said, between the 45 and 60 for the example that we are doing. It gives us what? The confidence interval, 60. And so it gives us the confidence interval CI. And we are saying that if this, we have our mean to be 50, and we have a confidence interval of this, we're saying we have 95% confidence that our population mean will be between that 45 and 60. So that's that with respect to that concept. So we have indicated a lot of different concepts. We started by talking about population, we saw the sample and so many others. If you read the notes here, you get details with respect to the confidence interval, significant level, hypothesis testing, and the degree of freedom is something we've not said, but we'll see it in application. However, if you check, you see that the degree of freedom refers to the number of values involved in a calculation that have the freedom to vary. Now, the concept about degree of freedom at times is a bit tricky, that if you're not very careful, you may find it a bit. Now, let's assume that we have three values, and three values, say 2, 3, 4, and a mean of 7. Now, we have a mean of 7 for 4 values. We know 3 of the values. We know 3 of the values to be 2, 3, and 4. Now, for our mean to be 6, the last value must be what? A fixed value. So 1, 2, 3 has the potential to vary, but the fourth value must be fixed. So in other words, the degree of freedom gives you the range of values that can change and will still be able to have the expected results. But to get the degree of freedom in our statistics, most often we have it as df minus 1. df is the same as n minus 1, which n stands for our sample, and minus 1 says that. Now, it's not fixed. In some situation, it will be df is the same as n minus k. And n minus k here represents what? K represents the number of variables of a study. For instance, regression, we use minus k. How many variables are in our study? So that's the idea about degree of freedom and how to get it. And so with that, we come to the end of the key concepts that we are supposed to get for this outline. We have not talked about descriptive statistics, but we'll see that when we start application. So what we need to do from here is that you'll need to send your emails. If you don't have the program, we'll be using SPSS to do the practicals so that the program should be sent for you to download and install in your machine, because when we come for our next class, we'll start with application. Remember, we have we indicated that our program is 95% practice, 10% theory. We indicated that this program is 95% practice, only 10% theory. And so get the program installed in your machine so that you can follow the classes and do the application. It's practical, so you need to actually you should practice it. And well, we will start with the basic descriptives. With descriptive analysis, we see descriptive analysis. We'll talk about inferential. Since we have not treated descriptive analysis as a concept, we'll see it and we'll do the application. We'll see inferential, we'll do the application, and you should be able to analyze data. With that, I'm sure we come to the end of today's class. I don't know if there is a question. If you don't have a question, I am sure they record the class, and so the recording will be, we'll share the link so you can download it and follow over again. Any question? Okay. Silence, I assume no questions. So we have our next class on Tuesday, 6 p.m. to 8 p.m. Assignment we given. I think we already have the assignment question in the platform. See you in the next class.